How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! Hello, distinguished guests, and welcome to Aquarium Bright. Here, you will get to see the most dangerous sea and ocean creatures. But don't let what I said mislead you. It's very well possible for you to come across one of these underwater animals during a walk on the beach. So take a look at them carefully now, and you might just avoid a disaster. Is it fish or is it stone? What you're looking at is commonly known as the stonefish, but its fancier names include the Dornorn and the Sinancia. If you're into diving and observing the underwater, you might already have come across one without noticing. Its appearance makes it almost impossible to distinguish it from a real stone due to its gray coloration and mottled appearance, especially if you're wearing fogged snorkel goggles, so you better pay attention because otherwise the consequences can be unfortunate since stonefish are the most venomous fish known. Although some types of stonefishes are known to live in rivers, and most of them are found in coral reefs near the tropical Pacific and Indian Oceans. Their needle-like dorsal fin spines stick up when they're disturbed or threatened and inject the poison they contain. The most common reason why stonefish stings occur is swimmers stepping on them without realizing it. However, you don't need to be in the water to get stung. Since they can survive out of the water for up to 24 hours, you'll have to watch where you step when you're at the beach as well. Those who got stung by stonefish describe their experience to be extremely distressing. Their venom can result in infection, and in some cases, it is known to cause shock and paralysis. It might come as a bit of a shock, but despite its bad reputation, stonefish is edible if it's prepared properly. When the fish is heated, its venom breaks down. And if the dorsal fins, which are the main source of its venom, are removed, raw stonefish is served as part of sashimi too. This creature might look like it came out of a science fiction movie, but it's very much real. Say hello to the blue-ringed octopuses. Don't be deceived by their small size, which can range between 5 to 8 inches including their arms, because they're packed with venom to cause great damage to as many as 26 people within minutes. Just like stonefishes, blue-ringed octopuses are found in the Pacific and Indian Oceans, from Japan to Australia. They typically live on coral reefs and rocky areas of the seafloor. Some may also be found in tide pools, seagrass, and algal beds. Blue-ringed octopuses are not aggressive in nature. When they're not seeking food such as crabs or shrimps, or searching for a mate, they often hide in marine debris, shells, or crevices. It's only if they're provoked, cornered, or handled that they get dangerous to humans. When they're threatened, they turn bright yellow or blue iridescent rings appear all over their body as a warning display towards the potential predators. Their bites usually come unnoticed, so you might not be able to realize you're bitten until it's too late. The venom of a blue-ringed octopus can cause dizziness and loss of senses and motor skills, and ultimately, paralysis. So better try to keep your hands to yourself and back away in a hurry if you see one. Nope, it's not a flower bouquet, so don't try to pick and smell one of those pink tube-like things. What's standing before your eyes is a marine animal called a flower urchin. It may look gorgeous, but don't let the looks deceive you. It was named the most dangerous sea urchin in the 2014 Guinness World Records. Flower urchins inhabit the tropical areas of the Indo-West Pacific. and are found among coral reefs, rocks, sand, and seagrass beds at depths of 0 to 295 feet. The most noticeable feature of them is their pedicularia, which are claw-shaped defensive organs that are also found in sea stars. What makes flower urchins differ from any other sea urchin is the fact that their pedicularia is, as the name suggests, flower-like, and usually pinkish-white to yellowish-white in color, with a central purple dot. Hidden underneath those flowers, they possess short and blunt spines. Although many sea urchins deliver their venom through such spines, flower urchins deliver their venom through their pedicularia, or flowers. If they're undisturbed, the tips of these flowers are usually expanded into round, cup-like shapes. On their surface, they possess tiny sensors with which they can detect threats, and once they contact such threats, these flowers immediately snap shut and start injecting venom. What's weird is that the little claws of the flowers can sometimes break off from their stalks, stick to the point of contact, and continue injecting venom for hours into whoever touched it. Yeesh! Looks like a giant puddle of melted strawberry ice cream, right? You wish. It's a lion's mane jellyfish, which is also called giant jellyfish, Arctic red jellyfish, or hairy jelly. They're known to prefer cool water. That's why they can mostly be found in the Arctic, northern Atlantic, and northern Pacific Oceans. But it's possible to spot them around the British Isles or in the Scandinavian waters too. Lion's mane jellyfish are one of the largest known species of jellyfish. They get their name from their long, flowing hair-like tentacles and can reach lengths up to 10 feet. And although the average bell diameter of a lion's mane jellyfish is around 20 inches, they can sometimes attain a diameter of over 7 feet. The largest lion's mane jellyfish recorded was seen in 1865 off the coast of Massachusetts. It was measured to have tentacles around 125 feet long and a diameter of 7 feet. To help you picture it, this is longer than a blue whale. Lion's mane jellyfish hunt by extending their tentacles outward and creating a trap to catch their food. Since they have around 1,200 stinging tentacles, the fish would have to be extremely lucky to be able to escape them. The sting of a lion's mane jellyfish is usually not life-threatening, but you would still want to avoid swimming into its tentacles because it can be very painful to humans. And if you see one washed up on the beach, better not touch it because it can still deliver a sting long after they've been on the shore. Fun fact, the lion's mane jellyfish appears in the Sherlock Holmes story, The Adventure of the Lion's Mane, as a suspect. But don't worry, we won't give you any spoilers. The last marine animal you're seeing now is a sea snake, and yes, they are different from eels. There are 69 identified species of sea snakes. Most of them can be found in the tropical and subtropical waters of the Indian and Pacific Oceans, and they have been around for millions of years. To make things easier, scientists have separated all different species of sea snakes into two categories: true sea snakes and sea kraits. Whereas true sea snakes spend almost all their time at sea, sea kraits can spend some time on land as well. If you see a snake on the beach, you can tell whether it's a land or sea snake by looking at its tail. If it's paddle-like, then that's a sea snake you got there, but make sure to keep your distance in both cases. All sea snakes need to surface regularly to breathe since they have no gills. That's why you can come across one while swimming. If that happens, you better swim away as fast as you can because most sea snakes have more venom than the average cobra or rattlesnake. However, since they only attack if provoked, bites are quite rare. One more cool fact about sea snakes: they are the only reptiles to give birth in the oceans. The majority of sea snakes keep the eggs within themselves and give birth to nearly fully formed snakes while swimming. That's except for the yellow-lipped sea krait though. They come onto land to lay eggs of their little ones. Remember the stonefish from the beginning of our tour? They're hunted by sea snakes. Blame the food chain. For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon: the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that ice quakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started. But not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet.
It took a lot of time for the light emitted by several incredibly old galaxies to reach the James Webb Space Telescope. After scientists made more precise estimates, it turned out that the photons had been on the way for over 13 billion years. That's about as long as the entire history of the universe, and only recently have they reached our orbiting observatory. These dramatic results have revealed that the universe started creating stars almost immediately after the Big Bang. But if you look at the images delivered by the James Webb, you won't be overly impressed. Just a handful of smudges, a few glowing spheres, and something resembling a dog bone. And still, the world of astronomy has been left speechless. The telescope's giant mirror has managed to capture the oldest known galaxy in the entire universe. The galaxy got quite a prosaic name, mostly consisting of letters and numbers. Yeah, that's rather catchy. It appeared a mere 320 million years after the Big Bang. In comparison with our home galaxy, this ancient one was tiny, but after its birth, it started vigorously producing new stars at a rate comparable to that of the Milky Way. Interestingly, the Webb Telescope has managed to photograph a few other ancient galaxies that had the same characteristics. Based on the snapshots of the baby universe we've got, we can conclude that in those ancient times, the first galaxies and stars were evolving amazingly fast. They also appeared much earlier than most scientists thought. Now, let's talk about the hero of the day, the outstanding telescope itself. The James Webb Space Telescope is a stunning piece of equipment. It's around 100 times more powerful than the Hubble Space Telescope, and the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion, the entire process of its construction cost around $10 billion. For comparison, NASA spent $4.7 billion to build and launch the Hubble telescope, and it was another $1.3 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. No wonder, during the manufacturing process, they underwent a 92% reduction in weight. The lighter, the cheaper it is to send stuff to space. If you had a chance to look at these mirrors, they would seem to be gold, but they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is still applied to each mirror, but they can't be produced entirely out of gold since this material needs to expand and contract even with small temperature changes. And that's not what we need to happen to a super precise piece of equipment. That's why the total amount of gold used in the construction of the James Webb Telescope is less than 2 ounces. That's a golf ball-sized chunk of gold. The gold plates covering the mirror are only 1,000 atoms thick. If we speak about all those incredible feats the telescope is capable of, it can clearly see a U.S. penny from 24 miles away and a football from 340 miles away. Hey, what's the score? JWST comes with significant advantages over any previous mission. For example, its 21-foot mirror is composed of 18 gold-plated hexagonal segments. They gather more than 6 times as much light as the Hubble Space Telescope's almost 8-foot mirror. It means that James Webb can record light from all kinds of space objects 6 times faster than its predecessor. The telescope's sensitivity to infrared light is also astonishing, which is remarkable since it can see different things than optical telescopes. You can say it's a real game changer. The James Webb can observe wavelengths from 0.6 to 28.5 micrometers, from the red end of the visible spectrum to the mid-infrared. As for Hubble's optics, most of the telescope's sensitivity is centered on visible light. It might sound surprising, but in its intended infrared domain, the Webb telescope isn't likely to resolve finer details than Hubble can detect in optical light. The thing is that although resolution increases with the mirror size, it also diminishes with wavelength. James Webb's telescope side cools itself down because otherwise it might get damaged or even burned. Normally its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cold enough to make hydrogen liquid. An enormous 5-layer sun shield surrounds the telescope and reflects as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll just keep orbiting the Sun. On the other hand, even though the telescope wasn't designed to be serviced or upgraded, it might potentially be refueled with the help of robots in the future. This might extend its lifespan. Anyway, here are the reasons why we can say this telescope has changed astronomy. For one thing, we might finally see dark matter. Around 84% of matter in the universe doesn't emit or absorb light. Astronomers call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. It affects visible matter, radiation, and the very structure of the universe. Dark matter is like some binding agent of our universe, and we're still not sure whether it exists. And now, thanks to the James Webb Telescope, scientists might finally have a way to seek dark matter. It's a huge development that is likely to change the way we observe the known as well as unknown universe. Even though astronomers haven't seen dark matter directly yet, they have been able to trace the distribution of this mysterious universal compound, all thanks to James Webb's powerful instruments. Another reason the new space telescope is so cool is that it helps us learn more about star formation. This process has always been a foundational part of astronomical studies. But even though Hubble has provided us with some iconic images and observations, there are still many unanswered questions about how stars form and go out. But astronomers are sure that James Webb will fill in the blanks. All because this telescope can peer further and deeper into the universe than any other telescope that has ever existed. Its location and cutting-edge equipment allow it to gaze through gases and dust surrounding early galaxies and stars. It will let us get a better look at star formation. It's also obvious that Webb's discoveries are bound to change the way we think of the early universe. For example, recently, the telescope has revealed several large galaxies that scientists believe existed not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. And still, the James Webb Space Telescope has spotted them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. The most bizarre thing about these galaxies is their tremendous size and the age of the stars inhabiting them. This information doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match the earlier observations made by Hubble. Astronomers hope that one day, James Webb will help us find new exoplanets and even detect water there. For a long time, astronomers have been discovering planets orbiting stars outside the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them, and reading unique signatures in the light can tell us about planets' chemical composition. The strongest and most readable signatures happen within the infrared spectrum. Have you just thought of James Webb's state-of-the-art infrared instruments too? They can help scientists spot new planets and even identify the presence of water there.
Jupiter has 79 known moons, and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt, boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But The ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the 3rd biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts: water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons. Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us. It's the planet orbiting it. That's Proxima Centauri b. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri b is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri b could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri b receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri b, this constant radiation would simply blow them off the planet. Proxima Centauri b is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright long-duration optical flare, accompanied by a series of intense coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri b, or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri b? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri b. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri b really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri b. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. and we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system, Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years, but in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even two moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb Telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.